So, I thought about doing it like 100% freestyle. So that is what we're gonna do. We're gonna cover cover a bit of shaders, or actually pixel shader, because we're gonna work with pixel shaders today. Then I want to go write a few 2D things, and I want to remarch stuff, or make a remarcher. Explain it too. And oh, there's 4 people listening. Hello, humans of the internet. No, there's one at the same time. Anyways, I guess it's just the way I'm too lazy just to re-record. So, okay. Anyways, let's not give a shit too much. We're gonna make a remarching algorithm, then probably take a look to Lambertian lighting. Okay, so let's start with a basic shader. I'm using ShaderToy, which is a tool that allows you to create some shaders, and these are pixel shaders. We could review a bit the GPU pipeline real quick. Not gonna go through it, but no, that's not the one. That's from the Learn OpenGL. That's the one I want. Just to show you a bit where we are working when using ShaderToy. No, is that no? OpenGL is this? I should have a place where I'm like, oh, this is it. So we work in the fragment shader, okay? So it's this part, and our code's gonna live in this. There's before the vertex, the shape assembly, geometry shader, the rasterizer part, and so on. But I really want to focus just on this fragment shader. So what is a fragment shader? A fragment shader is a shader that runs for every pixels of the image simultaneously. Let's write a few little tests before. Okay, so basically everything this shader do is, and I'm new, okay, to this new YouTube broadcasting stuff, so sorry if it's okay. So let's say here we have the same. Oh, it doesn't draw. It didn't draw. Let's say here we have the same thing as our ShaderToy. What the fragment shader is doing is running. Let's take brush, and for every pixels on this canvas, which in our case is 420 per 330, I guess 36. So this program runs for every pixels, and everything this program does, it processes some the code we feed it. Now the code is here, and it returns a color. So at the end we have a vec tree, and a vector tree is simply a color, out color, okay? And it can have values between 0 and 1. So it's like RGB. Let me just show you real quick. We're gonna review a little bit how the shader works. So, okay, so let's say we define a vector. We say col for color. Then we define a vector. We could enter 1. This is valid because it basically says 1 for the 3 channel, the R, the G, and the B for complete white. Then if we pass it like this, it's the same thing. Then if we want to only have red, what we could do is put the G and the B to 0. This is now red. One way I love to express this idea is, let's say you have float R is equal to 0. Let's say you have another float which is G and it's equal to 0, and we have float B which is equal to 0. We could define it like this: RG and B, RGB. So now everything is set to 0. So it's like if you would open into your favorite software and turning knobs. Knobs are for, let me just show you. If I put this one to 1, it's all red. If I put this to 1, it's all green. And if I put the last one, it's all blue. So it runs for every pixels, and this is something you need to wrap your head around, is that this piece of code is running for every pixel on the screen. So what we could do, let's review a little bit of things. What about making the color change based on the position of the screen? So we have here a beautiful UV pre-made. To debug stuff, you just plug them and you see how they behave. So if I go uv.x here, it's gonna give me the UV from 0 to 1 on the x-axis, and on the y-axis is gonna give me the same thing. So what I could do is pass this guy here to the R, and just say RGB, and now we have 0 to 1 for red. We could make it we can make the green have this UV thing from 0 to 1, so uv.y, and I would see that as x progress, it becomes all red, and as y process, it becomes all green, and as x and y progress linearly, we blend to yellow, which is a composition of red and green. So it would be the same thing as if I say, well, not really, but just to show you, now it's all yellow. But what we do is we say uv.x and uv.y. So, okay, let me just change this music. It's so annoying. Maybe I'll get flagged by the... Now we're getting... Okay. So we have uv.x and uv.y, and we could just blend them using this way. We could multiply, let's say we want the blue to be something like uv.x times uv.y. Now the green channel is simply having this value. We can see this value by plugging it here. And yeah, so you kind of get the idea. The thing is, we take the UV and we modify it based on, well, we plug the UV value into the RGB channel, and we plug then into the color, and the color is having the RGB. Well, it has the value of this, but okay, let's us go back to a 0 0 0 0 and a 0. There's also mathematical functions, so we could say that the red is going sine wave. We can make the sine of uv.x, okay? That would give us the same thing, but what we could do is start to make, let me just open Desmos, which is a tool you always work when writing shader. You always work with this guy. So, graphing calculator. If I go sine of x, it's like this, right? So if you make uv like dot x, like sine of uv.x, which in this case is x, or it could be anything, and you say times 12, you start to see those kind of more tight frequencies. So let's have, and now it get back to 0, and so we want to, there's many ways we could remap it from 0 to 1. Okay, we could do, but what I love to do sometimes is just say absolute value, and now we're gonna see that here. Okay, absolute, oops, screen is a bit too small at this time. Okay, okay, so now and if we make it better, like bigger, then we so that means that the red channel is like oscillating between 0 and 1, and we have black and then full red and then black and full red and black and full red and so on. So we could take this value example, so we could say now I want my green channel to be the same as my red one, so that would give us the same pattern but with yellow. But we could add more, so we could do something like the cosine of uv.y example times let's say 120 divided by 2, that would give us 60. So now we start to see how we can combine these operations to, and this is very annoying, let me square root. Okay. No, it was yeah, not sure, it's a bit too intense. Let me, what we could do is go times 0.09 0.7 0.5. Yeah, just makes it a bit darker. Then we could make the green channel be like double what we send the frequencies in the sine. So let's go I don't know, 220, like this. This would squish based on the y-axis. I'm not sure it is that important, but I just find it nice to review some of the kind of the basics. So we could say that the b is equal to like a tan of r and b forever, whatever. Oh, that is disgusting. So and we could say multiplies by the sine of time. Okay, what's up with that? Okay, so now it would slowly change. Yeah, very subtle, but still works. We could go and define a factor for a float scaling factor. And if we say 120, and then we could just plug it here, not scaling but frac. We could just times f and 2 times f here, times f times 2, right, and change this to be like 12. Now we see it better. It's a bit annoying, to be honest. The color is a bit intense on the eye, but anyways, you kind of see the idea. I'm gonna go on my GitHub, and I'm gonna create a new, not a new repo, but a new. I would like if we could make. Let me go. Can I create a git of gist? No, that's not what I wanted to say. I'm just gonna get up and create a repo. Well, actually, I have a repo where I put all my shaders. So, shaders. I'm gonna. Can I create on the fly? Add file. Oh, that's awesome! I can do this. Didn't know. I definitely did not knew I could do this, which is very nice. So, go to file. It's been a while since I've used GitHub, and it's somehow pretty fresh. Let's go add file, create new file. I'm gonna call it shader YouTube s01.glsl, I guess, and I'm gonna copy paste this into this, and now we have basic shader 1. Okay, what did we had on the menu today? We had covered a bit of shaders, of pixel shaders. This is, I think, quite done. We cover a bit of shaders, of the pixel shaders, We saw how we could divide the color, combine them, apply some little matty tricks using cosine and sine and so on, and then throw them into the channel, and then pass them to this guy here, and then it outputs to the screen. So yep, I guess I could probably also yeah, now the color is changing. We could make it change faster like this, because if we increase the time, it's like turning the knob of being from, or we could actually even go sine here. I think it would work better. Okay, yeah. Yeah, what about making it into polar coordinate? Now I guess we're at the thing of we write a few 2D things. This is a very I'm just gonna create here. So to pass to switch to polar coordinates, Cartesian to polar coordinates in 2D, you're doing this way, and then you take the length of the UV. That would makes it work, but it's gonna be strange. Let me show you. If I go to st.x, because it starts at the left corner, so we need to switch it back to the middle of the screen. So that's another shader I've done. I could cover it later. Then let me just, okay. Oh, no, it's crying. Yes, I know. Double. Okay. Not sure it's correct. That doesn't seem correct to me. Effect 2, the A-tangent of uv.x and uv.y. Oh, okay, yeah, I guess it's because, yeah, we need to add 0.5 plus 0.5, I think. Oh, no, sorry, because it's correct. Okay, now we have it. Okay, st.y, sorry, because I had the st.x, not a st.y plugged. And that's why. Let me just wipe out this guy and, oh no, that's not real. So what I could do is say something like uv is equal to st. That would make the whole thing. So instead of scaling based on of sine and cosining and generating those color based on Cartesian, we would remap or query them actually, or generate those signals oscillation based on the polar coordinates. So what I did is I just say, okay, here's my UV. ST is like for polar coordinate. I could say PC would make more sense, and then I could just say PC to Y, and now I could. Yeah, I could just replug my RGB node, not node, but so now we have the same kind of pattern, but in polar coordinates, and we can have even more fun. So if we scale it up back, now it's very ugly, but we can make maybe 2 and 3 and 4 and 5 and so on, and yeah, I'll like 12. Now if we animate, then it's not the most exciting effect, but still, and now we already have a kind of perspective, not perspective, but you know how our eyes kind of go through the center of the screens. Yeah. So what about if we multiply it by 2 or 12? Oops. We could increase the angle, so the length of the UV plus side time. Would this work? UV plus vec2 itime. Itime on the x, yeah, and 1 on the y, or I could go itime times itime. Ooh, that's way too much. Way too much. Way too much. It's so now what we do is, yeah, we do not, it's not correctly handled, but the thing is we somehow scale the length of the UV in Cartesian space, and we had to this a vec2 which is itime on x, and we had itime on y. If we multiply, then you can start to have some weird effect like this. That is effect, sometimes it's nice to work, but if you make your shader run for a long time, it's just gonna break. Like, it's gonna turn to shit real quick, cause then time is like going, it's gonna run for the not for the end of time, but it's gonna run through a lot. So what I could do is just say plus, and well, now it kind of does the same effect, but as it's adding, it doesn't kind of squish, so it just kind of, it's like if we travel the UV, so because if we multiply, we take the original, and then we kind of, now what we do is we just add to the original, so yeah, so that is something maybe you would want to do. 12, and now it's going very faster on the y. Itime plus 2, or you know what, times 0.025, and let's just point multiplied by 0.5 here. Yeah, it's kind of ugly now. Okay, now we see it well. Look, now here's the original UV. And then if we had vec2, we take this UV, the length of the UV, and we kind of had both on the x and the y, and we can see the y here is going. So if I okay, so now we can see it's going a bit downer. So let me just scale it up so we could see maybe at 25. Now we're gonna see it at the beginning. Look. It's moving 0.5 of the time, and it's going one, so like every second it's going half the seconds for the elapsed time since the beginning of the shader, and itimes times 1.25, it's like 1 second and 15 actually, 1 second and 1/4 faster. So let's make it back 0.25, and we could already see now. There we go. Okay, I'm gonna say something like, we could even scale it bigger. Now this is disgusting, but yeah, anyways. Yeah, and what I love to do is, you know what, take the code, plug it into your shader, and have fun. Just explore with them, because when you start to learn, and I'm still learning, so I guess it just makes more sense if you just take the code and jam it into your basic shader code. That is another one. Okay, 002. I'm gonna open a little treat for, and now I think we're gonna not review, but I'm gonna go on some basic things I do all the time on ShaderCoin, and that what probably makes it, I just want to see if it's well playing, and I'm going to show you if things like loading a texture, how to switch the UVs of a texture, things like this, because it's always easy. It's very easy, but I realize it's easy when you know how to do. When you know how to do this. I'm sorry, I have Tourette syndrome. When it's getting tired, late night like this, yeah, I can sometimes have strange noise coming out of my body. Yeah. No worries, I'm good. Just to make you know. So let us wipe everything and let us just leave the color. Oops. Photo curtain can make sense too. Make tree. And we're gonna say it's gonna be here. We're gonna start to white, all white or all black or 0.25 or 0.5. I don't. Let me just remove this kind of gamma correction we did. Color. Cool. And now we could go, yeah, maybe later in the stream we're gonna go on why we do square root of the out color. It's Inigo Quiles who actually he talked to me about it in a show we did together, and it was very interesting. So now let us add a we needed to load the texture. So when you start using Shader Toy, you will see there's a bunch of channels. Channels can handle many things, but in most of the case, you could load music from SoundCloud, have the webcam, microphone, cube maps, yeah, videos too. I didn't know there were videos. Let us try this. Oh wow. Okay, so we could query video now on Shader Toy. Interesting. I didn't know we could do this. Okay. But no, let's get back first texture. So there's gonna have a bunch of texture. Choose the one you want. Example, this rock tile. And then it would make, you would be like, oh, why doesn't it have here in the viewport? Well, the reason is that we need to query this texture and then pass it to the output color. So to do this, I have the line of code here, but I'm gonna rewrite it. What we're gonna define is a vector. I'm gonna call it texture brick, and you use the texture functions, and you pass it the channel. So in this case, it's I channel 0, and then you pass it the UV. What do we have here? Error. Okay. Oh, that RGB. Yeah, right. True that. And now we could plug the texture brick inside of our out color. Texture brick. Okay, now the UV is a bit fucked up on here, so because it's from 0 to 1, because we start a sample from the center, so we could probably make times 2 actually. Yeah, no, actually I think it was correct. I can make sure. Anyways, so let me just leave it to UV. No, it's a bit moved, but anyways, you still, now that's because we have fucked the UV. So the thing is, we would need, because normally if you remap the UV from 0 0 bottom to 1 1 top, now I'm taking the UV of the viewport, or not the viewport, but the UV we've defined on top. So that's why, because our UV now is from 0 to 1, minus 1 to 1, sorry, on it. So it's like 0 is center of this is 0 0. Not sure. I'm not sure. It's okay. So now we have the brick texture. We apply it to the color and then so on. So you could plug it time to. Now it will grow to infinity, not infinity, but as time goes in. But I'm gonna leave it to 1 because yes. And now it's important we have the RGB, where we could only query the red, the G, and the B too, but yeah, we could do the same thing. We can start to invert color, so BRG, that would switch RGB value of this out to this one. So yeah, I guess just leave it RGB for now. And we can use this texture, yes, to display, but also to affect some stuff. So let me show you. If we go to, we define a red RGB. Can I do this? I'm not sure. Seems like I can. Equal to 0. Let me just go to RGB here. Oops, RGB. And if I go to R is equal to texture break dot R, that would basically be the equivalent of taking the red channel. So like example, if you take Blender and you would open in Blender like shader. Where's shader? So if you had a new shader, you know, normally when you had texture, what you would do is go texture, texture, basic, like break texture, and you would like to split the RGB, you would go to split, vector, never forget how this one works in Blender, vector mat. Can I do this? Can I just split? How do I split RGB in Blender? Anyways, you kind of get the idea, right? So now we could say that is equal to G and B. Now we would have the same RGB, and now we would have the same texture back. We could also query the texture 2 times, but with different UV. So what about using our polar coordinate from preview? From the previous, we have that. Let me just step back. We don't want to fuck around with the X and Y. So, okay, texture break 2. Just gonna say PC here. And now if I go to texture break 2, let me try this. Yeah, we have the texture mapped around. So we could, what is nice is actually at this point we can start to combine the 2 images. So let's say out, so we could texture break plus texture break 2. Now we have the 2 combined. They're very ugly, but we can multiply them. Now it gives you like one pattern into the other, but that's yeah, probably not the most nice thing. Well, you could go sign of this guy. Times 12, and now you start to have those kind of old, disgusting Photoshop effects and texture break. Oh, I could just say plus. So actually, let me just make it absolute. Then you start to play around based on the signal of this, based on the texture, really. So, multiply. I don't know if it's something you would like. So we have the 2 patterns and based. Now it's because we threw the sine wave just to alter the first But we could also go with cosine here. I love to work with sine and cosine. It just kind of blends so well together, or divided. But I multiply. Or make it half. So now we just have kind of the have the riddling effect. So the thing is, we say, okay, we have sine, we have the texture brick, we multiplied by 12, and we sign it then we say absolute value. So it's from 0 to 1, and it kind of bounds like we saw earlier. But now I can change by half what we do here. So it's then, instead of cosine by 12 like this, giving us this, we reduce the frequency of, or like the, just like we saw, we kind of make it, instead of like this, we make it frequency higher. So by 2, meaning gives us this pattern. 8, you start to see it if I put 12 and so on. Well, at the end of the day, it will change the final output. Play with it. I think good ideas come to those who try stuff, and I'm just gonna go here and put it on my GitHub, and I'm gonna say basic shader tree, basic shader code number 3. So have fun, go on the GitHub, take the code, fuck around, change things. It's getting late, actually. It's almost midnight. I haven't seen, I'm live since 41 minutes, so okay. Let's do because the thing is, I would like to go with ray marching, but I think it's gonna go to tomorrow. Let us let me what about if we go to the sinus of phi time in here? Ooh. No, this is very ugly actually, but oops, I don't like it. I very don't like it. Anyways, we have something to play around. The thing is cool with polar coordinate, it's between 0 and 2 pi. So if you scale it up the angle, it's always gonna be it's always gonna, actually, let's go pc.y. I'm gonna show you what I mean. Plus equal to what's going on? Times? Okay, no, it's not time. I'm not sure what I just said, actually. I think I'm getting a bit tired at this time of the night, because okay. Oh, now it had, so it kind of make it suck in. Yeah. If we go minus, it's gonna go the other way around. Oops, minus. Now it's like if the, okay, so here's what happened. Oops, let me just, yeah. So here's what's happening. We take the UV from 0 to 1, as we saw earlier. Then we create a polar coordinate based on a radius and an angle. And sometimes you see this, right? So one common way to think about polar coordinate is this way. So normally what you have is a circle. Pardon my terrible drawing skills. You have the center. You have, like, example here. And someone would say, okay, here is, like, what's the coordinate of this point, right? And you would say, oh, well, it's easy. X is like sine of theta times r, and cos theta r, where r is the radius of the circle. I always forget if you if it's the one or the other way around. Ah, damn. Okay. Getting very tired at the moment. Anyways, that's another subject, not for tonight. Then what we do is we multiply the angle after it. So it kind of scale the polar coordinate in which we throw into the texture brick. If we go 2 here, you see it's kind of change the repetition of how we query the texture, so on and so on. 12, you see a lot now. Okay, this is very disgusting actually, but let me put it back to 1. And now we kind of push it. So if we would like to rotate, length would be, oh yeah, we would need to multiply just here, UV plus equal 15. I think this would rotate, but I'm not sure, and that doesn't seem to work. Okay, interesting. Not saying it's not nice, but I'm getting lost. I had a plan of what I wanted to do, and now I'm like, I don't know what's going on. I could go high time. Okay. Oh, because we affect the U and the V. Yeah, sorry, my bad. Okay, that's what happens. Now we see. Now it kind of worked, but because we scale the U, V, it doesn't make sense. So we want to remove this guy here, and then add it to. Yeah. So now, I'm not sure. This is what. It's live coding session, right? So, it's just a shader jam. It's not a. Okay. I kind of love the effect, actually, to be honest with you. Yeah, I mean, very not saying it's properly done, but the thing is, I would have loved to rotate just the angle, but I can't, so for some reason. Let's, I think it's because I'm doing it. I need to do this here too. Okay. Oh, I will go review. I have to review a bit more. Okay, anyways, it was just a little test. I wanted to make sure it worked. So have a good night.